Hey everyone, myself Sriniwas Paliwal and welcome to the first lecture of the data structures and the algorithms course by the ML Hub. So in this lecture, we will be discussing how to deal with a problem or specifically a data structure problem and the course outline, what topics, what data structures, what algorithms we will be covering in this course. So let's get started. Starting with solving a problem. Right? So whenever we encounter with a problem, like we always make a mistake to jump over the solution, but this is not the right way. At the end of the day, we have a problem of which we want a solution, or more precisely an efficient solution, right? So there is a 4-step basic process in order to get the efficient solution, right? So let's see. So whenever we encounter a problem, generally the problem is given in the basic English statement, right? A basic English language statement. So before jumping on the solution, what should be the first step? The first step is to understand it, to understand the problem. Understand the problem. Which means what exactly the goal of the problem is, what exactly it is trying to ask, right? So this should be your first step to understand a given problem, right? So once you have the basic understanding of the problem, then comes the modeling aspect. The modeling aspect. You have to model the problem. And what exactly is the meaning of modeling the problem? Is to choose. You have a buffet of data structures that we're going to be covering in this course. So out of all these available data structures, what should be the best fit for the specific problem? That's why first step is always to understand the problem. Otherwise, you won't be able to pick a appropriate data structure to solve it. So modeling is to pick a appropriate data structure. To pick an appropriate data structure. Right? So this is step number 2. First is to understand the problem. Second is to model it out. Okay. Once you have chosen the data structure, then comes the third step. Is to pick an algorithm. We will be discussing many different types of algorithms in this course. So once you have finalized the data structure, the next step is to choose that which algorithm you will be picking to solve this problem. Third is to choose an algorithm. And choosing a specific algorithm, to choose a specific algorithm, you should be able to analyze different sort of algorithms, that which algorithm is best or efficient for solving this specific problem. So choosing the algorithm also comes with understanding the different algorithms, analyzing the complexities of these algorithms, and come up with a conclusion that given two algorithms to deal with the same problem, which one you should choose, right? Based on the requirements. That's why understanding the problem is most important thing. You understand it, choose a data structure, pick up an algorithm which is efficient enough to solve the problem, and then the final step. Step number 4 comes, what exactly step number 4 is? To implement it. Step number 4 is the implementation part. Which is, you have a logic, you have an algorithm, you have to code that algorithm into a code snippet so that the computer or a machine can understand. So converting the logic to a code is what implementation is, right? And in this course, we will be dealing with step number 2 and step number 3 in a brief manner. We will see the available data structures that we have, then the algorithms we have. Implementation part we have already covered. So if you are new, you can refer the Python programming course that is available on our YouTube channel. So implementation part is done, right? And the first step, which is to understand the problem. So we will discuss this more briefly, but you will get better with practice, right? But there are certain things that you can take care to ensure the better understanding of the problem. So let's get started. The first step, understanding the problem. Okay, so generally a problem would be given you like this. So I have a reference example. Let's assume we want to find the maximum number in an array. So this is a very simple problem. A problem can be as simple as finding the maximum element in an array, or as complex as a minimax algorithm where two players are playing against each other in the game theory. But it starts with an statement. It starts with an English language statement, right? Okay, so there are certain parameters that you can check in order to have a better understanding of the problem. Let's see. First is, what exactly are the requirements of the problem, which means what is the goal of the problem. What is the goal of the problem? In this case, the goal is to find the single largest value. In this example, the goal is to find the single largest value, right? So first seek for the requirements, right? Then once the requirements are clear, check for the constraints. Are there any limitations on the input size? Are there any limitations on the time or in the memory that which you want to solve the problem? Seek for the constraints, whether there are some constraints given or not with the problem. For instance, the number of elements total might be less than 100. This can be a constraint, or so on, right? Third comes input output. So what are the format, what are the types of, what are the data type of the data that the problem is dealing with, and the range of data. This comes under input and output. So check this as well. Fourth is the edge cases. Think of whether there are some corner case scenario that you might encounter for the specific problem, right? So these are the four broad parameters that you can check to have a better understanding, right? And this you will get better by solving more and more problems in understanding aspect. Okay, so next, step number 2, which is modeling the problem or choosing an appropriate data structure, to solve the specific problem, right? And what exactly a data structure? A data structure is a way. A data structure is a way to organize, store and manage the data, right? More or less any problem you seek or encounter will always deal with the data. So somehow you need to find different ways in order to manage that data, in order to store the data and organize the data in such a way so that it can be accessed and modified efficiently for the specific problem at hand, right? So for that, we have to understand what are the available data structures that we have, right? So we will thoroughly discuss all these data structures in this course, right? So let's discuss what are the data structures we're going to be covering in this course. First module would be on linear data structures. First module will be on linear data structures, which will contain array. So this we have already covered in form of list in the Python programming course. This is already covered in Python programming. Right? In the form of lists. So there is a lecture on specifically on arrays that is covering the first linear data structure, right? But we will thoroughly cover linked list in this course, and not only linked list, specific types of linked list as well. So we have 3 variations of linked list: singly linked list, doubly linked list, and circular linked list. So we will be covering all three of them. So we will cover linked list. Then we will cover stacks. After that, queues. And in stacks and queues as well, we will also cover their application. Okay, so idea will be, we will see what exactly a data structure is, how it is implemented, how certain operations, in case of a stack, how push and pop operations can be performed, in case of queue, how NQ and DQ operations can be performed, and their applications, right? So this will be the linear data structures. Second would be non-linear data structures. So once we are done with the linear data structure, we will discuss trees. We will discuss trees, right? Regular trees, binary search trees, AVL trees, and tries, right? After tree, we will discuss graphs and then heaps, right? So these three non-linear data structures we will be covering. Okay, then third category would be hash-based data structures. Hash-based data structures. So this is also very important when it comes to searching, inserting and deleting the data into a data structure in constant time. So this is also an important data structure, and we will be having a thorough discussion on hashes. We will be having a thorough discussion on hashes, where we will cover linear chaining. We will see hash functions, what different types of hash functions are available to us. It might include division method, multiplication method, universal hashing, which is out of a pool of different hashes, a set of hash functions, we will pick a specific hash function and then perform hashing. Then we will discuss open addressing, which again will be having linear probing, quadratic probing, and double hashing. So we will be having a thorough detailed discussion on hashes, linear probing, quadratic probing, and double hashing. Right? So this is an important data structure. Why? Because it allows us to perform the basic operations on any data structure, which is to search, insert, or delete in constant time, in constant average time. This average term is also important. Why? We'll see it later. Then sets. So again, set is already covered in the Python programming course. So we won't be revisiting sets and arrays in this course, right? So this is covered in Python programming. Alright. Then there are certain specialized or advanced data structures. So out of which, in the first part of this course, we will only cover priority queues. The next three will be miscellaneous. We will cover it, but we will cover it at the end of the part 1, right? But priority queue is important, we will cover it. Okay, a specific type of queue in which the NQ operation is done based on the priority. Either it can be a min priority or max priority, we'll see, right? Then the next part, once we have a good understanding of these data structures, of these available data structures, so we will be able to choose a specific data structure to solve a problem, right? So once the data structure is finalized, the next part is to choose an algorithm, to come up with an algorithm which should be the most efficient one to deal with the given problem, right? So what exactly an algorithm is? An algorithm is a finite step-by-step process or procedure to solve a problem or perform a task efficiently. So this efficient term is important. The step-by-step approach, which can also be treated as the logic. Second is, the logic should be efficient. The logic should be efficient enough to solve the problem, right? So we will cover different types of algorithms in this course. Let's see. Okay, so the first module will deal with searching. The first module will deal with searching. Given a data structure, can you search a specific value or a node in it based on linear fashion or binary fashion? We will cover both of them in the first module, which is searching. Correct? The second will be sorting. So there are different techniques. Sorting is basically a process to arrange the elements given in a data structure either in an increasing or a decreasing fashion. So we will cover bubble, selection and insertion sort, which are not that efficient. Big of n square is the time complexity of these three algorithms. Then we'll see more efficient or divide and conquer based, out of which like merge and quick sorts are divide and conquer approach to sort the elements out along with heap, but these are more efficient compared to the previous three algorithms. Okay, and finally some more miscellaneous algorithms, radix, bucket and counting sort. So the third is like an easy one, but it will be miscellaneous, right? The main sorting algorithms we will cover first. Then we will discuss, once searching and sorting is done, we will head towards trees and graphs. We will start with trees and graphs. So generally trees and graphs are also a kind of data structure, but we will discuss them along with their algorithms. We will first cover the tree data structure, then its algorithms, and same for the graph, right? So in tree algorithm we will see tree traversals, different ways in order to traverse or read the nodes given in the tree. I am not going into the details for now, but we will cover different techniques of tree traversal. Then we'll see binary search trees, a specific type of tree called BST, binary search tree. Okay, then we'll discuss BSTs. Then balanced and segment trees, specifically AVL, redback least. So we won't be discussing these trees in that detail compared to BSTs and regular trees, but we will touch upon them. And finally tries. So tries will be the miscellaneous topic. We'll see at the end, right? Then comes graph. So both trees and graphs are important algorithms or data structures, right? So in graphs, first we will see graph traversals, which are the ways in which we can read the nodes of the graph, mostly BFS and DFS algorithm. Then the shortest path algorithms, Dijkstra, Bellman-Ford and Floyd-Warshall. I'm not going into the detail, but we will cover these algorithms of finding the paths from point A to point B, or the last one is the all pair shortest path, right? Then we'll cover topological sort. So ordering in a directed acyclic graph. What if the nodes of the graph are directed ones? So the edges of the graph are directed. In that case, there is a specific sorting, which is the ordering of the nodes in a directed acyclic graph. Topological sort, we'll see that. And finally, the last one will be under the miscellaneous section. We'll cover union find and DFS based techniques in order to find the connected components in a graph, right? So after trees and graphs, next comes greedy algorithms. And dynamic programming. These are also important algorithms. Okay. So in greedy algorithm, what exactly the greedy concept is, and different types of, or the what are the main algorithms or the popular algorithms of this category we will be discussing. And Huffman and MSTs, minimum spanning trees, and Huffman coding are important from the gates perspective. Okay, then comes DP or dynamic programming. So in specifically gate DA we do not have DP, so not in gate DA, but it is recommended to understand the dynamic programming approach to solve these problems, even though it is not part of the DA curriculum, but it is there in CS, and it is like important for interviews and placements. So you should, like, even if you are preparing for DA, you should cover DP, right? Okay, so what are the two approaches in order to deal with dynamic programming problems? Memoization and tabularization. So we will discuss thoroughly, and the popular examples including the traveling salesman problem, Fibonacci 01 knapsack, and so on. Right? Okay. So after DP we will be having two more again miscellaneous modules. So these will be miscellaneous as well. The first is combinatorial and constraint solving, a very popular category of algorithms or approaches known as backtracking and game theory. Then bit manipulation, and finally string algorithms would be in the second last module, right? Out of which backtracking and game theory we also discuss, like we also cover this in AI. Out of which minimax is specifically an important algorithm under adversarial search. Right? Okay, and finally again one more interesting module, number theory. So we will also cover these algorithms, right? Okay. Then before jumping on the algorithms, so we discussed thoroughly the different types of algorithms we will be covering in this course. Now the important question is, given a specific type of problem. Now let's say given a specific type of problem, you have three different algorithms to solve the same problem. To solve the same problem, you have three different types of algorithms. Out of which these three algorithms, what algorithm you should choose would be best for the given problem. This is what the complexity analysis is, analyzing different types of algorithms, based on the requirement of the problem, and either it can be based on time complexity. You might have that algorithm A1 is faster than A2 and A3 but might take more space. So it depends upon problem to problem that which complexity you are trying to optimize in order to have the final efficient algorithm or the solution for this problem, right? So we will be discussing it thoroughly. We will cover time and complexity analysis. We will cover different asymptotic analysis where the big O notation is the worst case scenario or the upper bound, omega is the lower bound, theta is the average or middle bound. So we will cover so that you can choose between different algorithms and come up with the final choice, right? Okay, finally there comes implementation. So there is a prerequisite for this course, which is you should have done a basic programming course. It is independent of the programming language. Okay, either it can be C, C++ or Python or Java. Everything is fine in order to have a better understanding of these data structures and algorithms, right? So prerequisite basic programming course must be completed in order to start with this course, right? And anyway, it is preferred if you have already done a Python programming course. If not, if you are seeking for the course, check out our YouTube channel. The Python programming course is already available on our YouTube channel, right? But it is a prerequisite. Now, before ending this lecture, who should opt for this course? Who should opt for this course, right? So if you are a GATE aspirant, if you are preparing for GATE, GATE, DA or CS, we have DSA in both of them, you can opt for this course. Or if you want to prepare for your semester exams, or if you are like preparing for your interviews or placements, you can have these codes or follow these codes. And why for semester and placements? Because we have designed this course in such a way that all the modules will be having theory lectures, we will be having lots and lots of practice and PYQs. We will be having practice problems and PYQs. And finally, the most important thing when it comes to understanding these data structures and algorithms, we will be having hands-on programming. Which will ensure that you will have a better understanding of these theoretical data structures by actually implementing them, right? So that's all for this lecture. See you in the class.